Hey everyone, feeling that pre-test anxiety creeping in? Well, take a deep breath because you've just found your ultimate study buddy. I am so pumped you're here for this explainer today. We are going to absolutely crush your final exam revision for Module 5 on vulnerability analysis. And look, we're going to aggressively distill this massive topic into highly memorable bite-sized takeaways. To do this, we're using a strict 5-step framework for every single concept. I'll give you a simple definition, explain the core idea, share a real-life analogy to lock it into your brain, outline the specific process you need to know, and then hit you with the one crucial key takeaway you absolutely must remember for the test. Sound good? Okay, let's dive into this. Here is your master syllabus for our session. We're covering 6 key areas: vulnerability classification, scoring and databases, management lifecycle, research fundamentals, scanning and analysis, and finally, assessment tool types. We'll hit every single one, so you're 100% prepared. All right, let's jump right into Section 1, Vulnerability Classification, categorizing the weaknesses. Get ready for our rapid-fire methodology here.
So, what exactly is a vulnerability assessment? In plain, everyday language, it's the systematic process of identifying, evaluating, and prioritizing security weaknesses in an organization's infrastructure. The core idea here is all about proactive security. You want to find the loopholes, whether the threat is from the inside or the outside, before the attackers do. It's kind of like a security guard checking every single door, window, and safe in a bank right before closing time, just to make sure nothing was accidentally left unlocked. The process itself involves running automated scans, physically and digitally examining the network, and then generating a detailed report so you can fix those issues. So your absolute key takeaway for the exam? Vulnerability assessment is all about proactive identification over reactive patching.
Now let's classify the chaos. Simply put, this is how we categorize the different ways a system can actually be weak. See, vulnerabilities aren't just one thing, right? They stem from bad setups, poorly written code, inherent design faults, outside vendors, or honestly just sheer laziness in updating software. Understanding the source is absolutely vital. Let's use some real-life analogies to anchor these in your memory. An application flaw, like a buffer overflow, that's like pouring a gallon of water into a tiny little glass. It just spills over into memory it shouldn't touch. A third-party risk, that's basically handing the keys to your house to a totally shady contractor. And poor patch management, that's simply leaving a broken lock on your front door for months on end. The process here requires an analyst to map the discovered flaw to one of these exact categories so the right team can fix it. So your key takeaway is this: identifying the specific type of flaw dictates exactly how you secure it.
Moving right along to Section 2, Scoring Systems and Databases. Basically, how we go about quantifying the threat.
Pay super close attention here because this is a classic trick exam question. What's the difference between CVE and NVD? Well, the CVE, or Common Vulnerabilities and Exposures, is just a public list of standardized names for flaws. But the NVD, the National Vulnerability Database, is the government database that actually scores those flaws. The core idea is that the global security community needs to speak the exact same language. So an organization called MITRE assigns a CVE ID to a flaw, and then the NVD takes that exact ID and adds crucial severity metrics and deep analysis to it. The perfect analogy to lock this in? The CVE is just the dictionary defining a word, while the NVD is the massive encyclopedia giving you all the deep analysis and impact scores. The standard process is pretty straightforward. A researcher finds a flaw, it gets a CVE ID, and boom, it's fed directly into the NVD for scoring. The key thing you have to remember: CVE gives you the standardized name, but the NVD gives you the severity score. And speaking of that severity score, it ranges from 0.0 to 10.0. This is the Common Vulnerability Scoring System, or CVSS. In plain terms, it's a quantitative, repeatable measurement of how bad a vulnerability actually is. The core idea here is brilliantly simple. It turns complex technical risk into a simple, universal number that everyone from IT to the CEO can understand. My favorite analogy for this is the pain scale at the doctor's office. You know, a 0 means you're totally fine, but a 10.0 means it is an absolute critical emergency and you need surgery right now. The process involves calculating this score using a very specific set of metrics that weigh different factors of the exploit. So, your key takeaway? The CVSS provides a repeatable numerical score so organizations know exactly what to prioritize and fix first.
So, how do we actually get that number? Well, the CVSS uses 3 specific metric groups to generate that final 0 to 10 score: base, threat, and environmental. The core idea is that some risks are constant, some change based on hacker behavior, and some depend entirely on how your specific company's network is set up. Think about a massive car recall. The base metric is the inherent flaw from the factory, like bad brakes. The threat metric is the current condition, like is it raining and icy out today? And the environmental metric is how fast you specifically are driving that car. The formula goes like this. You calculate the base score first, then you modify it with the threat metrics, and finally you adjust it using the environmental metrics to get a highly tailored score. The absolute key thing to remember here is that base metrics are constant and intrinsic to the flaw, while threat and environmental metrics provide the real-world context.
Great job so far. Let's hit Section 3, the Vulnerability Management Lifecycle, which is essentially a continuous loop. Simply defined, this is an ongoing 5-phase process to identify, assess, and remediate security weaknesses before they can be exploited. The core idea to grasp is that IT environments are literally always changing, right? New threats are always emerging, so your management of them has to be a continuous loop to actually evaluate risks effectively. The best analogy here is an annual health checkup. You don't just go to the doctor once in your entire life. You go in, you get a baseline, you get assessed, the doctor prioritizes a treatment, you verify the treatment worked, and you continuously monitor your health. It's the same here. The exact steps are pre-assessment to create a baseline, assessment to run the actual scans, post-assessment to prioritize the fixes, verification to rescan and confirm the fix worked, and finally, monitoring for continuous security. The crucial key to remember, vulnerability management is a continuous cycle. It is never a one-and-done task.
Okay, Section 4, Vulnerability Research Fundamentals, Staying Ahead of the Attackers.
What is vulnerability research in plain language? It's basically the active process of utilizing resources to identify and analyze the newest security threats. The core idea is that an ethical hacker needs to keep up with the most recently discovered exploits. By doing this, they stay one step ahead of the attackers, alerting network admins before a breach ever happens. It is exactly like reading the daily neighborhood watch report so you can upgrade your specific locks before the local thieves figure out a new way to break in. The process involves constantly checking resources, things like the Microsoft Security Response Center, deep or dark websites, and newly released security alerts. The key takeaway for your exam is that effective security relies entirely on this proactive research to identify design faults before exploitation even occurs.
Almost there. Section 5, Scanning and Analysis Process. Finding the gaps. This is where we move from theory into the actual methodologies.
This comparison between active and passive scanning, vital for your exam. In short, active scanning sends traffic directly to a target, while passive scanning merely watches traffic go by. The core idea is that active scanning simulates a real attack to uncover deep flaws, but it heavily consumes system resources. Passive scanning, on the other hand, doesn't touch the target at all, making it stealthy and zero impact, but it relies only on what information naturally leaks over the network. The analogy to lock this in: active scanning is actively rattling all the doorknobs on a building to see if they are locked. Passive scanning is sitting across the street with binoculars, quietly watching people enter and exit to guess the security layout. The process requires an analyst to actively choose which to use: active scans for deep testing and passive scans for highly sensitive critical systems that might crash if they're probed. The key thing to remember here: active interacts directly with the target, while passive only observes.
Now, let's look at the 3-step methodology that vulnerability scanners use to actually process network data. The core idea is that a scanner doesn't just blindly throw exploits at a network. That'd be chaos. Instead, it methodically finds active machines, figures out what software they are running, and only then tests those specific programs against known weaknesses. Think of a detective. First, they map out a house to see which rooms exist. Then, they figure out who lives in each room. Finally, they check to see if those specific people left their windows open. The exact steps of the process are: 1. Locate nodes, 2. Perform service and OS discovery, and 3. Test those specific services for known vulnerabilities. The key thing to remember is that scanners always locate and identify targets before they test for specific vulnerabilities.
All right, final topic on our syllabus. Section 6, Assessment Tool Types, the Hacker's Toolkit.
So, these are the distinct categories of software tools used to perform vulnerability assessments. The core idea you need to grasp is that no single scanner does absolutely everything. You need host tools for servers, depth tools like fuzzers to discover completely unknown flaws, and application layer tools specifically designed for web traffic. Think of this as a master mechanic's toolbox. You wouldn't use a hammer to change a spark plug, right? You need a highly specific tool depending on the exact engine part you're diagnosing. The process here is straightforward. Define the scope of your assessment, and then select the exact category of tool designed for that specific environment. Your key takeaway? You must always match your assessment tool type directly to your target environment.
Okay, study buddies, let's end with a mock exam check to validate everything we just learned. Listen to this question carefully. If an analyst uses the CVE dictionary to identify a flaw, which database should they consult to find its impact score and severity metrics? Have you got your answer? If you screamed NVD, the National Vulnerability Database, you are absolutely correct. You nailed it? Just remember our key takeaways today. Classify your flaws, know your CVSS metrics, remember that management is a continuous life cycle, and match your scanning tools to your target. You have put in the work today, and you are going to absolutely crush that exam. But as you walk out of that test, I want you to ask yourself a question. With new zero-day vulnerabilities being discovered literally every single hour, how long will today's security practices actually keep us safe tomorrow? Keep that focused energy up. Good luck on the test, and keep learning.